All right, yo, Ethan. Let's roll through this. I'll make this a video so you can like replay it. And this is all like graphing stuff. So I figured I should draw stuff out, and it'd be easier to do it like this. So it wants to use the graph to plot a graph of the inverse of f. This graph being f, y equals f of x. Then we're gonna need to find this value where the inverse of f um, is well, we want to find y because f of x is equal to y. So we want to find when x is 3, what um, what y is. Yes. Um, so let's begin. Or no, sorry. We want to find what x is. We want to find technically when f of x is equal to 3. Yeah, that's what we're trying to find. We're trying to find our y value. We're trying to find our y value here. And then, well, whatever the x is that makes this 3 when we're using, not the first, the negative first, the inverse, yes. Okay, so let's start by flipping this graph around, right? So we got 1 point, 2 points of interest, 3 points of interest, 4 points of interest. We got 4 points. So what we're going to do is x, y, x, y. We're going to flip these. You can also think of them as a, b. We're just flipping them. So we're trying to find BA or YX. That's going to give us our inverse. I can change the color here. If we do this, we get our inverse. So this point up here, we'll do blue for normal, or do this indigo or this whatever color this is for inverse. So this point is going to be -2, 4. So then the inverse is going to be 4, -2. Just flip them. Then this point is going to be, and I'm moving it all on the x-axis. So we're going to go 0 and 2. Then the inverse is going to be 2, 0. And let's go right here. We're going to go 1, 0. So the inverse of this is going to be 0, 1. Then bottom down here, we got a point that's 3, -2. So the inverse of that is going to be -2, 3. Sick. So then we plot these. I'll plot these in purple. Or I'll plot, yeah, in purple. So we got 4, -2. That's all the way down like here. 4, -2. 2, 0. Could be right there. 0, 1. Could be right there. Then -2, 3. Could be there. Connect them. When we connect them, it's really easy to see how they're the inverse of each other, right? They're like just see all this empty space just right here, right? They're inverse, they're flipped, inverse of each other. Sick. That's all you got to do for that. And then we want to find where f of x is equal to 3. So what point makes that happen? When x is 3, the inverse is at -1. So all we say there is let's do this in orange. F of -1 when x is 3 is equal to -1. See that from here. Sick. All right, next problem. This is like a weird graphing one. It's not like too difficult. Talk about transformation rules. So we're transforming this g of x into this f of x. So what do we gotta do? We gotta flip this, right? Flip this along the y-axis, the x-axis, Then we're gonna move this up to match, and also looks like right as well, right? So we're moving up, we're flipping over the y, then we're moving up and right. So find a rule for f in terms of transformations of g. Okay. So we know that what g of x is equal to log 2 base 2 of x. We have to flip first. X gets shifted over the y-axis. So we go, let's go make it our x negative. So negative x. So our first thing, we're going to reflect over y-axis. So go negative x. So our first transformation is going to be 1. Different color. It's going to be log 2 negative x. I believe that should be right. Yes. Then we're shifting right by, are there any variables here? Use typically h and k for these kind of things for um, up and right. So now for 2, we'll go right by value h. So go right by value h. That's going to look like, I believe this should look something like log 2 negative x plus h, just. And then we're shifting up by something, by k, right by k. I don't know what variables you're supposed to be using here. H and k are kind of standard. So 3 would be log 2 negative x plus h plus k. Up and right, positives for both. Yeah. That's kind of straightforward. I think that's what it kind of wants you to do. So you get the transformations being it wants it find a rule for f. It wants a rule for f. So we go instead of g of x to equal. So this is what g of x is, but now these are all equal to f of x because this is what we're finding. I guess only the last one technically is because that's what we're left with. Yeah, and I think that would be a suitable answer. Let's do this in a different color. Sick. That should be a suitable answer then for f of x because x is the transformations of this of g of x. So we transform this. That gives us that transform. Okay, last one. This is like a nightmare, honestly. It wants you to graph. I assume like loosely. I'm gonna really assume loosely. So we can look at these and like also talk about what's going on kinda for the transformations, the graphic transformations. So this actually would be negative, I think actually, now that I'm thinking about it. Because it's opposite, so negative h, negative x minus negative x plus h. I actually think that's more right now that I think about it. Um, Sorry, negative should be on the outside. Because yeah, when you transform, when you shift right, you actually go minus, and that shifts right. Yeah, sorry about that. Just make sure, yeah, that makes sense. So this would go out here, negative. Okay, I hope that makes sense. The right shift is minus, the up and down is still positive and negative, but the right and left is the reverse. Okay. then 9. Yeah, this is a mess. This function, we gotta know what it looks like. Gotta know what 2x, 2 to the x looks like. Gotta know what ln x looks like. That's all fun stuff, right? The parent function for all of these, uh, 1/3 to the x. I'll draw some graphs. I'll draw some cute graphs really quick. Actually, I think I can draw these graphs like this. Oh, nope, that doesn't work. So this is going to be 1/3 to the x. This is going to be 2 to the x. Oh, shoot, sorry, I should be writing this correctly. F of x equals g of x equals, we're going to go h of x equals ln to the x. Equals ln of x. Okay. Let's talk about these transformations, or I guess we can just like draw some rough x to the 1/3 or 1/3 to the x exponent. It's gonna look like this kind of. Wait, I'll draw all of these in these colors. Wait, I'll just draw them in the colors that they're written. So this is the parent. Should look something like that. Then 2 of x should look something like maybe this isn't actually. 2 of x should look. If you have 2 of x, you start. These are all like no's. You just gotta know these, like what these look like. Like look up pictures of the graphs, and you should know these. Um, but 2 of x is gonna look like, since it's a whole number, it's gonna look like this, roughly, roughly. Then ln of x, that's like easy. That's your natural log, right? So that's your let me look up natural log so don't butcher it. ln of x. This is just your. It looks like a mess. ln of x. Sorry, these are a little sloppy. Okay, so let's look at these transformations. Okay, for the first one, x minus 2, then minus 4. So that's going to mean what? It's going to mean that we're moving to the right. X minus 2, we're shifting to the right. Right 2, because we're minus 2. With x minus 2, you always flip that, right? So it's x plus, so move to the right. It's like the opposite. Then minus 4, we're just minusing 4. That means we're just shifting down 2 units. So this one's relatively simple. So right 2, down 4. Should look something like point, down 4. Something like that. Yep. Right 2, down 4. Draw that to scale. Probably a little better. 2x, 2 to the x. What are we flipping? Oh, wow. We're multiplying by -3 on the outside. We got that x plus 4, and we got plus 1. So we got, for sure, up 1, left 4, right? We see this, the x plus 4. So left 4. Look at that -3 out front. So -3, right? So it's a negative, right? So we're going to flip over the x-axis. You just got that negative out front. So you flip over the x, y, x. Flip over that x-axis, and then it's a whole number out front. So we're going to vertical stretch. If it's less than a whole number, we horizontal stretch. So flip it over x. Let's just go up 1, left 4, flip, then vertical stretch. So should get something like, if I flip this, boop. So it's gonna be like, boop, something like that. I don't know. Let me look this up real quick. Yeah, that looks about right. Yeah, that looks pretty good. Starts there, vertical stretch. So it's more sharp. It rises way more sharp than this one, which is like, this one's gonna like lag behind a bit. Yeah. So you get that up 1, left 4, then you get that -3, the -3. -3 is gonna be vertical stretch, and then it's gonna be flip over x. Um, then this last one, ln of x. What are we doing here? Negative, negative, minus. We're for sure down 2, right? See that clearly, right? Get that -2. Let me make sure I'm doing this right. This one right. For sure shift down 2. So down 2. What else do we got? What else do we change here? Looks like we're gonna, oh, this is a mess. So if we rewrite this as x ln, because we can distribute this, right? Ln of x minus 3. I think we can do that, right? That's fine. We can see that we're shifting over right 3, right? Because we get this x minus 3. Right 3. Then what's going on with this minus out here? We still got this somehow, right? Like there's a negative out front. That's clearly got to mean something. Or oh, you don't even have to distribute here. Actually, you shouldn't distribute there. I don't think you can't distribute there. I'll take that back, actually. Let's not distribute here. Let's just rewrite negative x plus 3 as negative x minus 3. We can do that, right? And we can see that in there. And then we see that negative outside. The negative outside is still a reflective over x. Yeah, I think that's how you solve that. Yeah. So right 3 we decided, and then we're gonna go flip over x again. So this is gonna look like a mess. Okay. So pick a point, down 2, right 3. So we're here now. Now we're gonna flip over the x. Y, x. So instead of being like this, it's gonna be like this. And I think this is good. Trying to think. I think that's right. Right? Right 3. We're flipping over that. Um, Let me look actually. Hmm. Get that negative out front there. Maybe you need to flip over. I actually don't know how to do this one, to be honest. I think what actually you do is something with this negative here. I think we're gonna shift over the x asymptote, x equals 3. So x minus 3 equals 0, x equals 3. So now we got this like dotted lines. We count, you know, 1, 2, 3 or whatever. So you get this dotted line right here. And then you actually, and so you get like to this point, right, where the thing is. And instead of reflecting over the x, we're actually going to reflect over, or do you reflect both? I think with the negative out front, right, you do the first reflection. And then with the next negative, you do, with the negative in front of the parenthesis thing, you do another reflection. So then you get like this golden answer right here. This is actually might be what we want. I don't know. Tell me if you have an answer key and that makes sense. Yeah, that's all your problems. This C1 is kind of tricky. I would look into that for sure. Um, I can look into it too if you need more help. I forget the exact rules you're supposed to do with that kind of stuff, with the extra negative and stuff. I think it actually is a double reflection. Um, you get some sort of double reflection. But yeah. Um, yeah, okay, sick.